Workshop tech. What do you understand by workshop tech? Huh? In engineering work, we might make notes and drawings. And we might think about a solution to a particular problem. Are you with me?
Yes, sir.
Thank you. We might find a solution to put down on paper when you are in a workshop. It is only the paper that will be given to you. You are going to work on the paper and make a craft, fabricating a particular structure that you are given to. What is workshop? Let's come to think of it under a tree where you put just a container and you put all your materials, your hand tools and machines, and you are working under the tree. That tree you are working under is a workshop for you. You may have a container, put it somewhere, and you begin to put one or two things together. When you are doing that, people will see you. They will know what you are doing. People will come around to tell you, Baba, what are you doing here? Okay, I'm into welding and fabrication. So people will begin to come with that container where you are. That container where you put your hand tools and your this thing is a workshop. That is a workshop. You might have a very big and large workshop. Take for instance in an industry or in a construction work place where you have a very large size of building that you call a workshop. Wherever you see a machine and tools and you are working with, that place is a workshop. Are you with me? And what do you understand by the word technology? Technology is the ability in you, the ability in you for you to make use of your knowledge, the acquired skill, and the available materials around you. Technology will make you to make use of the draft of a particular object. When you apply the knowledge that you have gained in the school, together with the skill, the ability to work with your hands, and the available materials around you. Take, for instance, you want to fabricate a metal door or a security gate. You want to fabricate it. Definitely, you will be in need of metal material like metal sheets, angle iron, prisms. So that is workshop in a nutshell. That is what workshop implies, and technology. So the two are working together. When you now talk about workshop and technology, you can define them as a place where all engineering activities are taking place. Engineering activities including fabrication, pipe and pipe fitting, block laying, and so on and so forth. And the technology there is the ability in you to make use of your knowledge, your skill, and the available materials. When you talk in terms of available materials, we are talking about, I think you are in plumbing. If you are in plumbing, you'll be very much conversant with the use of a plastic pipe and so on and so forth. But if you are in welding and fabrication, definitely you must be using metal material. How do we get metal material? How do we get plastics material? That comes under identification of materials. How do we identify all these material? Take, for instance, metal material. A metal material is organic material that you get from the innermost part of the ground in form of ametite or magnetite. When you smelt it, you remove all the impurities. Are you getting me? Then you have your metal when you remove the impurities. The end product of this process, of the smelting process, Because for you to remove all the impurities, the amethyte and magnetite, which is the raw material that you gotten from the innermost part of the ground, has to be smelt. You must smelt it. When you smelt it, you are trying to remove the impurities and take the original iron. Then you pour it into an ingot. When you pour it into an ingot, you keep the ingot somewhere for it to cool down. And when it cools, it becomes solid again. So the solid metal from the smelting material is called the pig iron. It's from this pig iron that you produce the very many types of metal that we have. We have two metals. We have two types of metal, which is the classification of metal. Are you with me? Are you with me, sir? Mr. Olumide?
Yes, I'm with you.
Thank you. Metals are classified into two major classifications. The first class is the ferrous metal, while the other one is the non-ferrous metal. What do you understand by ferrous metals? These are metals that can be attracted to a magnet. That is the simple language that I can make use of to enable you to understand and differentiate between ferrous metal and non-ferrous metal. Are you with me? Because ferrous metal contains iron, while non-ferrous metal does not contain iron. An example of ferrous metals are mild steel. We have a cast iron, we have high carbon steel, we have the low carbon steel, and very many types of steels. Any steel, any metal material that can be attracted to a magnet is a ferrous metal. We have a lot of tests that you can carry out on a particular metal to determine whether a particular metal is ferrous or non-ferrous. You can carry out structural tests. You can carry out magnetic test, sound test, and so on and so forth. It is contained in your coursework that you are having with you. That is that about metal. What about plastic? Plastic may be synthetic. It might be natural. The other one might be synthetic. The one you get from natural is the one you get from the tree, from the rubber tree, in form of latex. And we have two major types of plastics as well. We have the what do I call it? We have plastic. We call it. I should not forget that name. We call it thermoplastic. Thank you. We call it thermoplastics and thermoset plastics. The thermoplastics is the type of plastic that you can melt and remold. Why the thermoset is not possible for you to remelt and remold. When you try to remelt and remold, the thing will fuse away and it will. All these thermoplastic material has to undergo a lot of processes before you can get your pipe, before you can get your other materials that you use in plumbing. So that is that about the two materials that we are going to talk about. So when you look at the coursework with you, we have a lot of activities in the workshop, which includes one, identification of material, measuring tools, we have marking out tools, we have cutting tools, we have folding and shaping tools, then we have finishing tools, finishing material. All these things we cannot go into details. The moment you have your coursework with you, I will just be introducing you into these activities in the workshop. Are you with me? Yes. One, the identification of material of which we have done, we have discussed that one. We have been able to identify metals, we have been able to identify plastics material. The types, the classes of metals, the classes of plastic, we have discussed that. We move straight to measuring hand tools. A very good engineer must be able to measure and measure accurately, because when you are going to fabricate or you are going to produce a particular structure, definitely nobody will come around and start telling you this is the size you must use. Hence, the need for you to be conversant with the various types of hand tools that we have in measuring process. One out of it is the metal something metal. I should continue. So one out of it is the scale rule. The scale rule can be made of metal, it can be made of wood, it can be made of plastics. But the best one that you must be conversant with is the metal type. The metal type is very useful when you are talking in the workshop, because the wooden scale rule or the plastic scale rule may be broken. It can be broken at any moment, at any point in time. Even the graduation along the length of the scale rule may wipe off, because you are using it constantly, and by so doing, the thing can get broken. But instead, you make use of metal steel rule. The steel rule is used for measuring linear measurement. When you say linear measurement, that is a measurement on a straight line. That is linear measurement for you. And the unit of measurement in the olden days, in the imperial days, is in inches, feet, and yard, which is still applicable these days, but it is obsolete. That measurement method is the process of making use of inches, feet, and yard or in miles is obsolete. They are no more in vogue. Though some people still make use of it, they will say, okay, measure out 10 inches. But it's no more in vogue. So the unit of measurement these days is SI unit, Standard International Unit, which is in cm, mm, meter, and kilometer. So for you to measure on a very straight line, you make use of a scale rule. Otherwise known, when you want to interpret it, you may say it is ruler. That is a grammatical interpretation of it. You may say it is ruler, but it is not ruler. We call it scale rule. Because on the surface of that flat metal material, there is a graduation in cm and mm for you to measure your linear measurement. There are other ones which we refer to as tape rule. Tape rule can measure as long as you want it to measure. You can measure about 1 meter, you can measure about 50 meters, and so on and so forth when you are using your tape rule. So both the scale rule and the tape rule, they are meant for measuring what? For linear measurement. It's for linear measurement. It's for linear measurement. The next one is, I'm coming now. The next one is the tri-square. Tri-square. You will see it in your coursework, the tri-square. I will need to refer you back, because I discussed with you that metal material has to undergo smelting process before you can get the actual metal out of the amethyte and magnetite, which is the raw material that you gotten from innermost part of the ground. This material, I'm still coming back to measuring tools, but I just want to introduce you to how a metal is being produced. Are you with me? When you gotten your amethyte and magnetite, you may get amethyte in Osun State, and you may have magnetite in Lokoja. Are you trying to understand what I'm saying? So if you annex this thing together, or you get one out of it, you charge it into a furnace called cupola. When you charge it into it, there are a lot of ingredients that you have to put into it before you can get your pig iron. So kindly bear in mind the processing of smelting a metal material before you can get the various types of metal material that we have. Now, coming back to the measuring tools, we've talked about the scale rule or the steel rule and tape. We have discussed that it is used for linear measurement. And there are two major ways by which you can measure out your distance, the imperial way and the SI unit way. The imperial way is where you are still making use of the inches, feet, yard, and miles. But the SI unit, which is the international unit, we make use of the centimeter, millimeter, meter, and kilometer. Are you with me? So the next hand tools there is the tri-square. Tri-square is made up of three major parts: the blade, the stock, and the screw, the fastening screw. If you look at the tri-square very well, it is in L shape. It has an L shape. The L shape is fastening to the stock with a screw. In most cases, riveting. They will rivet the blade into the stock. Why do you call it tri-square? It is tri-square because the blade and is at 90 degrees to each other. It is perpendicular. Do you understand? The blade is perpendicular to the stock. It maintains a 90 degree with each other. Hence, you say it is square. Tri there implies that this material tri-square, you use it for finding the squareness of your work, the squareness of your fabrication. When you are fabricating a metal, or you want to cut a metal, or you want to cut a plastic, you can measure it with tri-square, because most of these tri-square we have these days has a graduation on them as well, like that of your scale rule or the tape rule. So you use tri-square for finding the squareness of an angle, So you can try it as many times as possible before you can get the squareness of that particular material. Hence, the name tri-square. You try it many times before you can get the squareness of the metal. Next is the surface plate. What do you understand by surface plate? This is a rigid metal material, very solid and strong. The surface is flat. It has been polished to zero limit. So the surface is very, very smooth, very smooth. How do you make use of this surface plate? The surface plate you see there is a solid cast iron. The surface is very, very flat, and you use it for finding the flatness of a particular metal. When you are constructing, you need to measure the flatness, how flat a particular metal is before you can, most especially those people working on lathe machine or any other type of machine that requires you to know the flatness of a particular metal. So the surface plate is meant for finding the flatness of a given metal. Are you with me? You can as well use it together with other materials. You can use it together with other materials to find the flatness of such a metal material. It comprises of three major parts: the flat surface, the handle, and the rib. So how do you make use of a surface plate? When you are using surface plate, or you want to use surface plate, so to say, you need to smear oil on that surface of the surface plate. You smear oil into it. Then you take your metal or your plastic material, then you rub it on the surface of the plate. If the oil covers the whole face or the surface of your metal material, which means that metal is extremely flat. But if it's not occupying, it's not found around the surface of a particular metal, which means the metal is not flat enough, you will take that metal or plastic for probably you grind it or you file it to get the surface very, very flat. The
Please,
next
sir,
one,
can you come back? Sorry, I'm very sorry. When you rub the oil,
When you rub the oil on the surface of the surface plate itself, you smear the oil on that surface first. Do you understand? When you smear this oil on the surface, then you take your metal material, you place it on the surface of the plate. Then you rub it on the surface of the plate. When you look at your metal like this, if the oil cannot cover the whole surface of your metal material, which means the metal is not flat enough.
Okay.
It's not flat enough. Then you have to regrind. You regrind, or you use a file to adjust where necessary. Then you take it back to the plate again. Then you rub it. If now the oil covers the whole surface of your material, it implies that that particular metal material or plastic is as flat as anything you can think of. Is that taken?
Yes.
Thank you. Next is the spirit level. The spirit level is a rectangular solid bar. It is a rectangular solid bar. It has a liquid. It has a liquid in front and by the side of the bar. Do you understand? Are you with me? And it is used for measuring. It is used for measuring or checking surface on horizontal and vertical plane. That is spirit level for you. Grammatically or locally, people used to call it plumb. Plumb is just a technical way of explaining things to the novice. You call it plumb. You call it plumb. If you are so conversant with these bricklayer people, the bricklayer make use of it mostly for checking the flatness, and for checking the flatness of their block when they are laying the block, for checking the horizontal and vertical plane when they are assembling the blocks together to make a wall. So they call it plumb. But technically, when you talk in terms of engineering and tools, we call it a spirit level. Spirit level. Because it has a spirit by the side of the rectangular solid bar, and one on the flat surface of that particular bar, such that when you place it straight on a particular metal material, if the metal material is not perfectly straight, you will see the liquid. You will see the liquid inside the tube. It will tilt to one side. And when you look at the one at the side, it's also the tube, the liquid will tilt to a particular side, which means that bar or that pipe is not perfectly straight, and you needed a straight pipe or straight metal material. You will now adjust that pipe, or you adjust that metal, or you change it, you take another one, then you check. When the liquid is at the center of that tube, it will show and you will see it. Do you understand? It will show you and you will surely see it. So both on the surface of the flat part and by the side of the tube, by the side of the solid bar, definitely you will see that the tube and the liquid inside is at the center on both sides. That tells you that your material is perfectly straight on horizontal or on a vertical plane. So it comprises of many parts. You will see the curved tube filled with liquid. That is on the flat surface. By the side, you will see tube filled with either water or another liquid. It might be spirit inside that tube. You will see the body. So that is a spirit level for you, spirit level. Micrometer. Micrometer. Micrometer is a precision tool. It is a precision tool. Precision in the sense that it can measure to the barest unit, 0.001 or 0.01 limit. Do you understand that? Can you imagine how little, how minute that measurement is? It is not possible for you to use your steel rule to measure that. You cannot measure that with your tape rule. Most especially if it were to be a round object. A round object. Not necessarily means that you can only measure round objects. You can measure anything using your micrometer. And when you are measuring, I am telling you now that it is a precision tool. Precision tools in the sense that it can measure to the barest unit of measurement. Are you with me?
Yes.
It can measure to the barest of 0.01 to 0.001 to 0.01 measurement. So that is the reason why we call it a precision tools. We have three types of micrometer. We have three types of micrometer. We have internal micrometer, we have external micrometer, then we have the depth gauge, micrometer depth gauge. Those are the three types of micrometer that we have. And it comprises of many parts. You will see the anvil, the spindle, the frame, the lock nuts, the scale, the thimble, and the ratchet. You will see it there. All these are meant for adjusting. In between the moving anvil and the fixed anvil, you will place your pipe that you want to measure to know the diameter of such a pipe. You will put it and you turn the thimble. You turn the thimble. When you turn the thimble, allow the spindle, the moving spindle, to hold the material in between the fixed anvil and the moving anvil. Then use the ratchet to fine-tune the tightening process. Use the ratchet. When you use the ratchet, it will enable you to get the precise size of that particular pipe. So you understand. And when you look at the other one that we have there, that one is used for measuring the internal micrometer. The first one is used for measuring the external measurement, while the other one is used for measuring internal measurement. So we have the other one, which is the depth gauge. The depth gauge, this will enable you to get the actual size, actual measurement of a particular depth of a hole in your material. Like say you want to cut a size of a plumbing material. An example of pipe now. You know the measurement. Maybe it is ½ inch or 1.5 inch or 1.5 meter or 1.5 millimeter of a pipe that you want to cut. You cannot say just unpick a pipe, say you want to cut it. You must measure and be sure that what you are measuring or the pipe you are having is the actual size of the pipe that you are, that you needed for your work. So you can make use the external micrometer to find out the diameter of such a pipe. And you can use the depth gauge to find out the depth of that particular pipe that you want to use. So the internal micrometer, the external micrometer, and the depth gauge, they are precision tools. Precision in the sense that it will give you the precise measurement to the limit of about 0.001 to 0.01. Are you getting what I'm trying to put across? Thank you. So that is that about micrometer. Then we now talked about the vernier gauge. The vernier gauge is similar to micrometer. It is similar in the sense that it is also a precision hand tools. It can also measure to the limit of 0.001 to 0.01. So it can give you the precise measurement of your material that you want to use. A vernier gauge or vernier caliper is similar to a micrometer, but in a vernier gauge or vernier caliper, most of these vernier caliper or vernier gauge put together the internal, the external, and the depth gauge in one. So vernier caliper might be 3 in 1. Excuse me. The vernier caliper might be 3 in 1, whereas the micrometer is separated from one another. We have internal micrometer on its own, external micrometer on its own, and the depth gauge on its own. But in vernier caliper, this is where the difference comes in. It is different from the micrometer, normal micrometer, because in a vernier gauge or vernier caliper, you can measure the internal, you can measure the internal measurement, you can measure the external, and you can measure the depth gauge of a particular structure. Though that makes the difference. That makes the difference. Understand? So all these hand tools put together, when you are in the workshop, you must make sure that you use them and use them perfectly well. And after the use, you must clean, probably with soap water, turpentine, petrol, or kerosene for further use. Am I saying something?
Yes.
Thank you.
Yes.
So, in terms of hand tools, we are stopping here today, but I want to introduce to you a measure, because by the time you get into workshop here, there are precautions. There are precautions that you need to observe. When you look at your coursework, you will see all these precautions there. All the precautions has to be taken care of when you are in the workshop. When you are in the workshop, if you look at your screen, you will see it there right now. Is that not so?
Yes.
Can you see
Yes.
it? These are the precautions for you that you must adhere to whenever you are in the workshop. Please and please put them into use by the time you are here and you are in the workshop. Because all these are precautionary measures that will prevent an unforeseen circumstance when you are in the workshop. Unforeseen injury that may cause a lot of things. If care is not taken and you fail to adhere to all these precautions, one will end up, which I don't pray for when you are here in the school. One, no horseplay. No horseplay. What do you understand by horseplay? I believe you must have seen horse. When the horse is playing, he will raise the two front legs and he will be jumping here and there. In the workshop, you are not supposed to engage in horseplay. How do you carry your own horseplay when you are in the workshop? You have a friend, you have been chatting together, you have been staying together, and you are in the workshop, you pat him. When you pat him, you run away. He would like to run after you. Such is not allowed in the workshop. You must not engage in horseplay, because in the workshop, we have a lot of revolving machine, like drilling machine, cutting machine, milling machine, lathe machine, and we in most cases we deal with hot material. Most especially those in workshop, those in WFT, welding and fabrication department, we deal with hot material. But if you are running escalator in the workshop and you fall into into a revolving machine. You know what it means. God forbid. Two, we have, you must put on your overall. Use of overall. Use of overall. Your overall must be put on when you are going to the workshop. This overall will enable you to put at bay all other fabrics in you, so they will not be flying here and there. The moment you put on your overall, you are good to go. You will look very smart in the workshop, so you can carry out whatever operation that you want to do when you are in the workshop. Three, use of covered boot. You must always put your covered boot on. When you are in the workshop, nobody will allow you to come with slippers, sandals, canvas, or whatever. It's not allowed in the workshop. You must always put on your hard-covered boot, as this will enable you, this one will, prevent any unforeseen circumstance, probably stepping on a very sharp object, probably on a very hot object or whatever. So this will prevent you from doing what? From having injury on your legs. On your legs. Four, no use of tie, chain, and bangles. It is against the ethics of engineering students to make use of tie, or you make use of a necklace, which otherwise known as chain. You don't use it. You don't use metal bangle. You don't use metal wristwatch. So all these are forbidden when you are in the workshop, because if you allow this tie to be entangled into a moving machine, a revolving machine, you know what it means when you allow your tie to be taken over by, before anybody can come around you. I don't know. So one has to be very, very careful when you are going to the workshop. You don't go to the workshop with tie. You don't go to the workshop with necklace, which is otherwise referred to as chain, or you go with bangle. I would have loved to give you an example, but we have a limited time. I would have loved to give you an example of what happened to a student when I was in the Polytechnic. But just let us take it as you see it. There will be no use of tie, no chain, and no bangles. So that is all these things are against the ethics of engineering students. You must not use them. Understand? Then 5, we use of gloves, hand gloves. I believe you know what hand glove is. Whenever you are in the workshop, you put on your hand gloves, just to prevent unforeseen circumstance or injury into your palm. Because in the workshop, you may have a cause to hold a very hot material. You may have a cause to grind. You may have a cause to cut with cutting machine. You must always put on your gloves while in the workshop. Gloves will prevent piercing of your palm, because if you have a very sharp metal material, you have a very sharp object to hold, and you are holding it with mere hands, definitely there is no cause to say piercing is inevitable there. So to prevent your palm from any injury, please put on your gloves. Next is use of goggle or eye shield. If you, wherever you are, be it plumber, be it welder, be it painter, be it any trade you find yourself, any course you find yourself, you must make sure you use your goggle. I don't know maybe whether you are a Yoruba man. Yoruba will say oju onipini ara. So when the eye is no more, man is useless. Because when you are working in the workshop, there is bound to be flying of metal chips, metal particles, and so on and so forth. Even solvent that is capable of spoiling your eye when you allow it to be splashed into your eye. Hence, you must put on your goggle most especially the plumbers and what? And the welders. For welders, you may have arc eye if you are not putting on your your goggle or your eye shield. You may have arc eye, or you may see particles of metal flowing into your eyes. By so doing, you know what it takes you to get rid of all these things, hence the need for you to make sure you make use of your goggle or eye shield. 7, do not obstruct the gangway. What do you understand by gangway? In a standard workshop, where you have a very big workshop with many machines, like filling machine, cutting machine, demarcated passages in the workshop. In that big workshop, you will see that area is demarcated to allow you to move freely in the workshop, so that it brings about free passages. Assuming there is an accident, and by the passages you put a very big metal material that will prevent people from moving freely, and there is an accident. You want to carry such a person out of the workshop? In the process, there is a blockage along the passages. What do you think will happen before you can remove that obstacle, removing that big okay, sir. So next, or substances such as grease, oil, water, solvent in the floor of the workshop. Make sure you clean a place where you see a log of water or pool of water, or you see oil being splattered on the floor of the workshop, or grease somewhere on the ground of the workshop. You must make sure that you keep clean the workshop, because if you step on any of these substances and you sleep, when you sleep, you may not know where you are going to hit your head, or maybe you will hit your head onto a revolving machine, and you know what it means. So the need for you to be highly observant when you are in the workshop, make sure that the workshop is clean. There is a provision for cotton wool, waste wool, and there is a provision for other material that you can use to clean the workshop. If you see any of these substances on the floor of your workshop, please make sure you clean the place. Take for instance, you are a welder and you are welding. You are using electricity. There's no doubt about that. And you have a peel of the cable you are using and a sliding valve on the water. The moment you touch the water, whether you are holding the wire, you are not holding the water, the moment you touch the water, the thing will shock you. It may throw you out of balance. So please, if you see any substance or substances on the floor of your work, make sure it is. Next is use of extinguisher. Anything can happen in the workshop because you are operating machine, you are working with electricity, you are working with very many gadgets in the workshop. In case of any fire outbreak, I repeat, in case of any fire outbreak, please run out of the workshop first. Put it in your left hand. Anytime, anywhere, even if it is not in the workshop, anywhere you see yourself and there is a fire outbreak, please run for your dear life. So in a workshop, if there is a fire outbreak, what you need to do, you must first of all move out of the workshop. It is you that you are safe that you can now come round to save others that has been caught in the web of the fire. Because when there is a fire, you will see that the smoke will engulf the entire workshop. Is that not so?
Yes.
So by so
Yes,
doing, so whenever you see fire in a workshop, please run out of the workshop. So it is you now that will now think that, oh, what can I do to help others that has been caught in the web of this fire? You now think of a fire extinguisher, because in a standard workshop, there must be a fire extinguisher put in the strategic places outside or inside the workshop. So if you are out of the workshop and there is fire, you first of all run out. When you run out, you now look for a fire extinguisher outside. Then you operate the fire extinguisher to help others and quench the fire. Am I saying something?
Yes.
Thank you. So
Yeah.
that is
Yes, sir.
that about the about the safety precaution when you are in the workshop.